Madhulika Kumar. She's completed her Master of Architecture in Architectural Association, London, UK. She then went on to work at Shanmugam Associates and integrated design on projects ranging from residences to regional planning, sustainable master planning, water calculation, etc. She was also known for her master thesis, which was selected for public display at AA, which was also selected for summer exhibition and shortlisted to publish at a national conference in UK.
Welcome to UGC lecture series for B Architecture. Today's subject is Sustainable Planning in Architecture, and today's chapter is An Introduction to Sustainability. So, the presentation is divided into 5 main categories: introduction, brief, concepts, ethics and vision, and conclusion. Sustainability can be divided into 2 main chapters: planning level and built environment. So, planning level consists of water calculation, sustainable master planning, regional planning, landscape and ecology, whereas built environment consists of achieving thermal comfort, materiality, energy efficiency, indoor and outdoor thermal comfort. So, it is basically whatever which can be achieved, made to achieve the thermal comfort within the building environment. So, what is thermal comfort? ASHRAE defines it: the condition of mind which expresses satisfaction with thermal comfort. So, thermal comfort is basically a state of mind. Different factors which affect the thermal comfort can be defined as environmental factors, psychological factors, physiological factors. So, now looking at the environmental factors, it can be divided into 5 main categories, which is dry bulb temperature, humidity, radiant temperature, air movement and solar radiation. Psychologically, the human's body heat balance can be measured by a steady state condition, which means by a moment of inertia and not after they are involved, the human is involved into a vigorous activity. But human beings do adapt to their environment, and their bodies can adapt to the surrounding condition to a certain level, and these factors affect directly the user through health, productivity, comfort, energy use and awareness about their surroundings. And moving on to psychological factors, different activities which contribute to the user pattern within the built environment also contribute to achieving comfort. So, different activities can be like sitting, standing, exercise, running or dancing. All these activities produce different heat levels which affect the thermal comfort, and these activity level can be measured in watts per meter square, and it differs for each activity. Say for sitting, it can produce 100 watts per meter square of heat, and whereas for dancing or exercise, it varies from 700 to 900 watts per meter square depending on the user, type of dance the user is involved and type of exercise a person can be. And moving on to other psychological factors or their clothing level. So, clothing level can vary from 0, that is completely being nude, and 2.5 to 3, which is completely using sweaters, jackets, and mainly in western countries. So, this insulation property adds to the achieving thermal comfort. So, we as being in a hot environment, we prefer cotton clothing, whereas people from western countries, they prefer woolen clothing, which also adds to the factor and which needs to be taken care of while designing. Say for a school building, the amount of clothing as uniform needs to be calculated before while considering a design. And physiological factors is adaptability, accumulation, past experience and time of exposure and culture. These factors or adaptability is a body can adapt to certain changes to environment which can be altered to achieve the thermal comfort. But whereas accumulation and past experience is when you come out from a very hot environment, and even though the room is still little bit hotter, but you will feel comfortable because of the past experience that you had of the outside environment. And time of exposure, if you are exposed to an uncomfortable thermal environment for a short period, it does not make a significant effect on the user, but whereas when exposed to a longer period, you do need to take care of other factors of length of exposure and how long the person is going to stay and factors affecting them. and culture. So basically, from which background you are coming to this type of a new environment to adapt to these type of changes. So these comfort can be calculated using these different factors by comfort calculator and psychometric charts, which has certain adaptable ranges to show the comfort level a person can achieve for different activity, different clothing pattern, and these are all available online, which can be used to check indoor as well as outdoor comfort levels. So basically all these factors depends on climate. And so climate is, we have a vast variation of climatic zones throughout the world, and it does not only just depend on the climate, but also where you are located, latitude, longitude and altitude as well. If you can see within the south of India, we have different climatic variation even in Ooty and Chennai. It's because of the altitude that place is located in. So climatic variables, so temperature, humidity, wind speed, solar radiation and illuminance. So these are different climatic variables which have adverse and direct effect on the thermal comfort. So while looking at temperature, you need to look at dry bulb temperature, radiant temperature and sky temperatures, and not just the indoor or outdoor temperature, and all these have different effects on the user. And the next factor is humidity, which you have to take care of relative humidity, vapor pressure and wet bulb temperature. All these comes under psychometric chart and how different factors affect the person's thermal comfort. And air movement. So the air movement can become a crucial factor for having good effect as well as worse effect depending on the climate that you are located in. So basically on a warm and humid day, you would prefer a cool breeze to pass on, but whereas in a cold day, you prefer, you are not exposed to such cold and humid conditions. So the design aspect should consider the direction of the wind and wind speed and wind temperatures as well. For a hot and humid climate, it is preferred northeast and southwest wind direction for tropicals, and whereas when you are considering design on western climates, it's preferred not to exceed almost 1 meter per second of wind speed. And solar radiation. Solar radiation is divided into global, diffused and direct and horizontal solar beams, which applies same as wind speed, in which for a hotter climate you need to eliminate direct solar beams on all the surfaces as much as possible, whereas on western climates it is welcomed on all sides how much ever is possible, on especially on the southern facade. And illuminance, global and diffused. In India, we have a good illuminance range from 7,000 to 70,000 lux. So using it in a very good effect can produce the environment without going for any artificial illuminance, and it can be completely used free of any conventional sources. And atmospheric pressure, cloud cover, precipitation, etc. And so climate change. So we all know that climate has been changing since the past, and there's been some studies which has been carried out, which shows from 1960 to 2060, for about 100 years, this graphic shows the different parts of the world which has different effects to the climate change. So in India, we can see almost 3 to 4 degrees of temperature increase, but whereas we can see adverse effect around close to Egypt and South of America, which will be very close to 6 to 7 degrees. Is it just the global warming? It seems to be not that. And weather projections are based on emissions scenarios input into the general circulation models. Different emissions that's been caused, like CO2, carbon monoxide, phosphorus emissions, which has been carried out because of different air conditioning and refrigerator usage, also has an adverse effect on the environment. And these are some of the charts which show different emission levels which has been increasing since 2000 to 2100, and CO2 emission, CO2 concentration per ppm, and emission scenarios, and which also affects the temperature increase. So you can see an adverse increase by the end of 2100 will be affecting due to all these emissions as well as the climate change. So the question is how to achieve sustainability now. So sustainability is not just the usage of material, but it also accounts the climate, envelope design, user comfort, occupant typology, microclimate and user pattern. Why sustainability is needed? So what we see around us, all the buildings are just heat producing machines, is how we have to look at it. So this is what buildings are telling us and what we are going to respond to it. So all these buildings produce tons and tons of carbon dioxide and carbon monoxide. So the issue and vicious circle, urban warming from AC, which is equal to, when there is lot of temperature increase, we depend on more on air conditioning, which more air conditioning is equal to more electricity generation, which is equal to need of more power stations. Electricity generation basically leads to carbon emission or other nuclear issues. So most importantly, now we have to look at it like a global problem, which is AC culture, which is equal to obstacle for sustainable design. So it's better not to create a problem and put on AC to just to compensate it. Architects should have a closer vision if we need AC in the first place or not. So this is a report by Times of India, which says due to there has been 16 hours of power cut every day in Trichy city, which is leading to low performance in academics in Trichy, which has to be taken care because it's affecting the next generation as well. So as architects and designers, we should be sensitive to the environment that's around us. In increase of mechanical systems, carbon emission is increasing, which results in global warming and non-renewable energy depletions. There are few different ways to avoid this situation. It's by understanding the climate and user, using passive design strategies to improve your energy bills, mechanical systems, or bringing lot of energy issues. So we need to go back to look at the past, how we have been constructing before to achieve the thermal comfort, and we have to take some of the essence and the learnings from the past, which can be used to making better environment presently and the future needs. Conclusion. So increasing global temperature, melting of Himalayan glaciers, more dependency on air conditioning systems, worsening microclimate effect. So all these are telling us, so we are going into a wrong direction. We need to stop and rethink of the whole design process that we are doing, and we need to be more and more taking in care of the climate and the environmental aspects that's surrounding us. So how can we be sure if what we are designing is sustainable or not? So sustainability is not something which can be taken for granted, or it can be assumed by putting some material that you have achieved sustainability to the 100%. So it is fundamentally a matter for architecture being an outcome of programmatic formula and operational choices made or ignored by design. So what Simos is trying to say is, it has to be a process in the design, and it should not be an added layer to your design. So while making the design itself, you need to consider the different climatic factors and what is surrounding you, the microclimate effect, and what is the user pattern and typology the building is going to be used, and the future scenario. It has to be adaptable not just for the time being, but it also should be adaptable for the future climatic ranges. So it can be tested in different tools and softwares. These are some of the tools which can be used to measure temperature, wind speed, surface temperature, and lux level. So which can give basic design intuitions to you, which will tell you how much you need to achieve and how much you need to do in your envelope design to achieve thermal comfort. There are some modeling softwares which can be also used to test your design basically. So these are DASM, which is used for daylighting, and Gecko the same, and NVMet is used for testing microclimate effects, and Energy Plus and soft computation tasks are all softwares which is used to test the thermal comfort, the temperature which is achieved within the built environment. And Ecotech, which we all know is environmental software, which can be used to test sun path and wind by WinAir plugin, and illuminance for daylight studies. Basically it's like a vicious circle which goes back. So you have your sustainable passive principles which can be used and adopted to make your building, and there are some of the tools that we discussed earlier which can be used to test how the principles can work actually, and these principles can be tested and it will give you a definite result which can be 90% reliable, and these results can be have a closer view for the user if it suits the thermal comfort required or not, and then you can go back to your principles and redefine them according to the need, and then you can test it again. So it is like a process which is a continuous process. You achieve till the results that you need has to be achieved. As we discussed earlier, now we are going to look to few of the comfort calculator tools which are available online, which can be used to test the thermal comfort. So now moving on to the first one is comfort calculator. So down you can see this link which can be used to download this website which can be used to check the thermal comfort. So this calculator takes into account air temperature, radiant temperature, relative humidity, air velocity and activity rate, which we discussed is the type of activity that the user will be adopting into the built environment, and clothing level. And the air temperature can be measured using different tools or from historical data, but the radiant temperature is average or mean temperature of different surfaces that is surrounding the person. For example, inside a built environment it will be walls, ground and the roof, but outside it can be different planes which is surrounding. Even the color can account to the radiant temperature, whereas if a person is standing surrounding a wall with cool colors, the reflectance will be very less, and he'll be actually having a very less radiant temperature compared to the actual air temperature. So the radiant temperature is very important, and also the temperature on which the occupant is resting, occupant of the user. So when we are exposed to a wet stone environment, the radiant temperature is less compared to when you are exposed on a hot concrete environment, concrete surfaces. And relative humidity is the amount of water vapor that's present in the air, and air velocity is measured in meter per second. It accounts the air direction and the speed of the wind. And clothing level is the cloth the user is using, and it has to take in account to all the clothing levels that the person is wearing, and this will generate by using different of these factors, it will give the predicted mean OAT, which is if it is almost 0, the bunny is happy, and the percentage of people dissatisfied is 0. Usually the percentage of people dissatisfied can be acceptable within 20 to 30%, and if it is more than 30%, then you need to redefine your environment and the different factors that is affecting the thermal comfort. And moving on to the next comfort tool is CBE thermal comfort tool, in which it is taking into account air temperature, the same mean radiant temperature, air speed, humidity, metabolic rate and clothing level. But this difference is more accurate because it takes into account different use of operative temperatures, and it also works under adaptive thermal comfort mode, which is actually the dark blue line is the actual temperature that person can be feeling comfortable, and the light blue or increased range of temperature within which the person will still feel comfortable, but with slight percentage of people dissatisfied, but even that is acceptable. So now, having a closer view to all these factors, now we are moving on to case study. So the first is, this is the climatic range for Trichy, which is in Tamil Nadu, India. So the comfort limit temperatures are calculated using Nicole and Rolf in Pakistan, which is developed, which shows the adaptive and cultural behavior in Pakistan is similar to that of the Indian context. The clothing and the surface and the culture context is all same. So we are adopting the same formula to find out the neutral temperature. So neutral temperature is Tn, which is equal to 17 plus 0.38 into To into AV. TOAV is the mean average temperature of the month. So it differs from January to December. There is one neutral temperature for each month, which has to be multiplied with 0.38 and added with 17, which will give the average temperature throughout the year in every month. So based on the relationship shows the neutral temperature, which is monthly dry bulb temperature. A comfort band is plotted using plus or minus 3 degrees Celsius difference, which will have a 90% acceptability for occupants. So having a closer view at the climatic variations from January to mid of Feb and from November to December, it's usually rainy season and the roads get flooded, and so which in turn will increase the relative humidity in the air temperature. But whereas from the month of April to mid of August, it's completely dry and the rivers get dry, so the air temperature is very high and also the relative humidity is very less. So you can feel the skin is very dry, and all these consideration has to be taken for seasonal variations also in the design. The most important factor for a hot climate is wind speed. So as a tropical climate, the city has two different wind directions, which follows from October to April it's the northeast, and from May to September it's the southwest, and these are different wind speeds which is occurring. So which shows a 4 to 5 meter per second of wind ranges, which is predominant in the city and which can be used very advantageous for the projects to be designed over there. And this is a psychometric chart which is developed for the city Trichy, and which shows different monthly variation and different months, and this orange line is the neutral comfort zone developed according to ASHRAE. These blue lines are showing comfort months with ventilation. So if there are ventilation, these months can be completely comfortable. And hot seasons vary from March to September, in which you need indirect evaporative cooling to elevate the comfort levels. And these green lines shows the different wind speed with which the comfort ranges can be elevated as well. And the next field work is going on to Kerala. It's Kerala Kalamandalam, which is located in Thrissur. So Kerala is located in 10.5 altitude and 17.21 longitude, which experience a typical warm and humid climate. So looking at the climatic ranges, it also has 6 months of monsoon, as we all know about Kerala, and usually summer to June is the typical summer, and the rest of the month is comfortable enough. And it is a campus setting in which it's a school for dance and music, in which the site is oriented towards the north, and the site experience northeast and southwest wind, and this is how the sun path diagram. So this is an open campus which caters to different needs between users, students, and it also has built environment and semi covered environments. So these blue spaces are the teaching environments, which is located very close to the wind flow directions, so which has to be taken into account while zoning the site. And these orange ones are the dance classrooms, which are also considerably close to the outer edge, which will have an unobstructed wind flow from both the direction, northeast and southwest. So now moving on to one particular building, this is called Kuthambalam, which is a space to perform dance. It's like an auditorium. So zoning of the Kuthambalam, you can see it is changing room at the rear end, and the performance space at the center, and the audience space at the front. And you can see there are screening walls which are surrounded on all sides. So this is how the solar screen works, and there is no solid wall which covers the building, so which allows complete airflow throughout the building. And these solar screens, it cut down the solar radiation completely, and it just allows the wind. So these two solar screens are like a buffer space, and this elevated space is the audience space, which is used for seating, and this wooden space is used for performers. So this snaps were taken at 12 o'clock at the noon, and you can see even during high solar radiation levels, there is no sunlight which is being exposed to the audience space, and it is just in between the two zones. And this space, which is the audience space, you can see it is covered with high eaves, which eliminates complete solar radiation and just allows the wind flow through the solar screens. And this is a typical makeup room which uses artificial lighting during daytime. This accounts to solar heating of the environment, which has to be taken into account. And there's one more interesting factor is people sit on the floor to view the performance. So this flooring has to be was made very cool in order to achieve thermal comfort. So different spot measurements were made at different points on horizontally on the Kuthambalam, which shows different air temperature. So it is interesting to note that even though the air temperature does not fluctuate more, the surface temperature of the floor has significant reduction, which can be used to achieve thermal comfort. And these are different lux level which is being which was measured at different points, which shows 82,000 lux, which is complete glare for a normal human eye. And inside, even though it's completely open, the solar screen are designed in such a way to cut down the glare, and inside it has 300 lux level, which is perfect for viewing an dance program. And also the account of dressing was taken, which the uniform used by girls were loosely fitted saris, and for the boys it was semi-naked new upper body, and then the lower body was covered with a towel and a pajama, which both allowed space for the wind to move in and also for the sweat to escape. So a small interview was conducted with these students, which was shown that classroom are comfortable, but they lack of space and light, and we like to have classes outdoor or under tree during evenings. This scenario is basically because of high solar radiation, which takes away the relative humidity and makes the air dry. So when it's under a tree, due to transevaporation, it feels more comfortable. And these are different tests which has been adopted by TAST, which shows different with 30% of opening window to wall ratio and 50% of window to wall ratio. Even though the temperature is slightly higher, 50% of window to wall ratio has good effect, and percentage of acceptability is higher compared to 30%. And these are 2 dates in which the auditorium was studied more in detail, in which the school begins with 9 o'clock and ends with 5 o'clock, and in which the different spaces was used, the space was used for different activities. In the morning it was used for teaching, and from 11 to 12:30 they had a performance with 150 to 200 students sitting, and from 1 to 2 it was a lunch break, and from 3:30 to 4:30 again it was a dancing activity. So as we can see, when there is a people increase from 80 to 150, there is a slight increment of 0.7 degrees Celsius. So what this says is the envelope is designed in such a way it is easy to release the heat which is being accumulated, even though there is a lot of people adding to the space. And even though there is 80 people dancing with a metabolic rate of almost 500 watts per meter square to 700 watts per meter square, the temperature increase is just 1.2 degrees Celsius, which can be neglected due to the wind flow throughout their body. So these are different factors which has to be considered while designing, and the flexibility that gives for the project. And the same study was carried out for the consecutive day, which showed same 1 degree of increment when there is 80 people dancing inside the classroom with respect to the outdoor temperature. Learning outcomes. So from this PowerPoint presentation, you will be understanding a brief introduction to sustainability, classification and factors affecting thermal comfort, climatic variables for thermal comfort, and introduction to sustainability and testing materials. Questions. How do you classify sustainable architecture? Define thermal comfort and its importance. What are the various factors affecting thermal comfort? How to prove sustainability for a project? And it's to be continued, and chapter 1 has a part 2 which has an introduction to Earth's carrying capacity and statistical comparison with present and the future, and key problems and identification from Stockholm's Renaissance Center, the maximal limit of the Earth, our interventions to save the planet. Thank you.